So today's lesson is over the inverses of logarithmic functions. Because logarithms are inverses of exponents, the inverse of an exponential function, such as y is equal to 2 to the x power, is a logarithmic function. And that logarithmic function is y is equal to log base 2 of x. Remember, base, right? So that's how we're going to figure this out. We're going to swap the x and y, and we're going to solve for y. So here, remember graphically how we tell they are inverses. The way we tell that they are inverses is if we look at some points. Remember, inverses mean x and y swap, right? So x and y swap, okay? So that means over here, if this is 1, 4, then down here we should have 4, 1, right? So notice here, let me move this so you can see that 4. This is 4, 1 right here, isn't it? So they did. The x became the y and the y became the x. So the domain of y is equal to 2 to the x power is all real numbers, right? Because notice here that the graph is continuing on to the right and to the left, isn't it? Okay, continuing that direction. And then the range, y is greater than 0. So why is it not equal to? Well, the reason it's not equal to is because this line right here, remember, is our asymptote of the equation y is equal to 2 to the x power, okay? So now, when we're talking about the inverse of y is equal to 2 to the x power, that is the function y is equal to log base 2 of x. So again, we're talking about the red graph now, and this graph, notice that it
this one's going to continue to go up and up and up, and it's going to continue to go down and down and down. So that means the range on this one is going to be all real numbers. That's what this is right here. And the domain this time is going to be y is greater than 0. X is greater than 0, because this time the asymptote is going to be this line, okay? So it's going to be to the right of that the whole time. So now we're going to do a quick review of how to find the inverse of a function, okay? So if you recall, if we have the function f of x is equal to 3 times x minus 7, and this is already on your paper, so just watch me. First thing we're going to do is change the f of x to a y. Then we're going to swap the x and the y. So we're going to make this x, we're going to make the x our y, okay? Then what we're going to do is we're going to try to get y by itself. So we're going to divide both sides by 3. That's going to give us x over 3 equals y minus 7. And then we're just going to add 7 to both sides. So it's going to be x over 3 plus 7, equals y. So, or we could also call it, we could say it's 1/3 of x plus 7 that's equal to y. So these are the inverses, or we could also say it's f to the negative 1 of x. You can put that instead of the y, okay? That's what inverse means, f to the negative 1 of x, okay? So now, that's all that was here on y'all's paper. I just worked it out so you guys could see me doing it. So now we're going to work some of these together, okay? So our first step is going to be to replace the f of x with the y. That's what we did with the last one too. So, and I'm going to put this in parentheses, okay, because it's together. So then I'm going to swap the x and the y. So this is going to be x equals log base 4 of 3y. Now my next step would be to put it in exponent form. So we can get the y by itself. Okay, so we're going to take this, our base, 4, and this, our exponent. Oops, sorry. And we're going to set that equal to this over here, which is 3y. So then our next step would, again, to try to get y by itself, would be to divide both sides by 3. So that means y is going to be equal to 4 to the x power over 3. And the way we can check this is by putting it in Desmos. So let me show you this. So when we do this in Desmos, I'm going to go ahead and put y is equal to and I'm going to go over here to my keyboard and then to the function key and over to miscellaneous, and we're going to do log base here because this one has a base. So this is going to be log base 4 of 3x. So that's our first function, and then we're going to put the other one in here as well that we just solved for. So we're going to do, I'm going to do it in parentheses, 4 to the x power. Oops. Yeah, go to the right and put it in parentheses, and then I'm going to divide that by my 3, and I'm going to set that equal to y. So immediately you should be able to see that these look like they're inverses of each other. And again, remember, the way I can tell that too is a reflection over the line y is equal to x. So if we pick a point here, so this point like here is 0.333, right? Okay, so if we try to find the 0 over here on this one, notice it's flipped. This is 0.3330. You can check other points as well. So you could try to find, okay, so this is 2. Let's see if I can get it right. It's close. Y'all see that? So that's like 1.29 is the x value, and it's 1.993. So down here again, if I try to do this, we're always looking for them to be flipped. Y'all got me? So let's just do this one right here. So this one's 0.024, 1.89. So if we look at 1.89 over here, let's go this way a little bit. I can't get it, but you guys get the drift. So we're looking for inverses here, opposites of each other, okay? X becomes y and y becomes x. So once again, let's work a problem together. So y equals log of 3x, I'm going to put that in parentheses, minus 5, okay? So this time I'm going to swap the x and the y. Oops, sorry, that's supposed to be a y, y'all. 3y minus 5. Okay, so before I switch it, I'm going to move this 5. Okay, so I'm going to add 5 to both sides. So now this is going to be x plus 5 equals log of 3y. Now notice there's no base there. So hopefully all of you guys remember that if there is no base, there's really a base of 10. Okay, so now we can put this in exponential form, right? So we can take this, our base, 10, to this exponent, x plus 5, and that's going to equal this right here, which is 3y. Then what do we have to do? Divide both sides by 3. So y is going to be equal to 10 to the x plus 5 power over 3. And again, you can check this in Desmos just to make sure that these two, this one and this one, are inverses of each other. Next one, y equals log base 1/2 of 2x minus 5 plus 6. Going to swap the x and y, so this is going to be x log 1/2 2y minus 5 plus 6. I'm going to subtract that 6 from both sides first. So this is going to be x minus 6 equals log base 1/2 of 2y minus 5. So now we're going to put it in exponential form. So we're going to take this, our base, 1/2, to this, our power, x minus 6, and that's going to be equal to this over here. So this is 2y minus 5. So now, how do we get rid of that 5? We're going to add 5 to both sides. So this is going to end up being 1/2 to the x minus 6 plus 5. That equals 2y. Then we're going to divide the whole thing by 2. So that's going to give us y is equal to, or f of x, f of negative 1, the inverse of y, right? So is 1/2 to the x minus 6 plus 5 all over 2. And again, you can check this by putting it in Desmos and making sure that this one and this one are inverses of each other. All right, so now we're going to do the inverses of exponential functions. So we're going to start this the same way we did the last one. We're going to do y equals 4 to the x power plus 6. We're going to swap the x and y. We're going to subtract that 6 from both sides. So it's going to be x minus 6 is equal to 4 to the y power. Now we're going to write this in logarithmic form. Okay, so once again, this is our base. So it's going to be log base 4 of what? This. X minus 6 equals y. So this is just flipping it. And again, check this and this to see if they are inverses of each other. Y equals 2 to the 6 times 6 to the x power minus 3. We're going to swap the x and y. Again, we're going to add that 3 to both sides. So this is going to be x plus 3 equals 2 times 6 to the y power. We're going to divide both sides by 2. So that's going to leave us with x plus 3 over 2 is equal to 6 to the y power. Now we can change it to a logarithm, right? So it's going to be, here's our base, log base 6 of this number. So this is going to be x plus 3 over 2, and then that's going to be equal to what? Our y, right there. Okay? I'd like to see if you guys could do this last one and come back to me when you're done. Y equals 5 to the x minus 2. X equals 5 to the y minus 2. So this time we have log, there's our base, of 5. There's our to the x, right? Is equal to y minus 2. So what do we have to do? Add 2 to both sides, right? So when I write this one, I'm going to say log base 5, and I'm going to put that x in parentheses because that plus 2 is not what I'm taking the log of. And that's equal to y. Okay?